Hello everyone, welcome back. Can you build a dice without using a random number generator? In this video, we will use a timer0, a simple shift operation and GPIO to create a binary dice in ARM7 Assembly. Consider this code. First, let me check if there are any errors in this code. No errors, so we'll go ahead with debugging. At first, we can see some assembler directives, that is area, which defines a section of memory to store this information. Dice is the name I have given to that section of memory. Code indicates this section of memory contains actual ARM instructions. Read only because we don't want any modification to be happening to this particular code during runtime. Entry indicates where exactly execution starts. Execution starts at the very first label that appears after entry. In between entry and start, we can see the assembler directive EQU. This assembler directive associates any human readable symbol with some value, which in this particular case is nothing but actual addresses associated with important registers. For example, this is associated with GPIO port 0 direction register. This particular address is associated with GPIO port 0 output set register. This is associated with GPIO port 0 output clear register. And this is associated with timer0 timer counter register. And this is with timer0 timer control register. GPIO port 0 direction register configures each port 0 pin as input or output. GPIO port 0 output set register sets selected port 0 output pins high by writing 1 to the corresponding bits. GPIO port 0 output clear register clears selected port 0 output pins low by writing 1 to the corresponding bits. Timer0 timer counter register contains the current timer 0 count value. It increments when the timer is enabled. Timer0 timer control register controls timer0 operation and it is used to enable, disable or reset the timer. Here start, roll, check, valid, delay, loop are nothing but labels. End is an assembler directive which indicates the end of source file. Now let me open my GPIO port 0. At the very first step, I'm loading the address associated with the GPIO direction register of port 0. And then I'm storing a value of 3F into R1. I do this because once that particular value is stored in the location pointed by R0, that is these locations, immediately the last 6 bits are set as output and their default value is 0. And open my timer. Okay. So as you can see here, I'll be storing TCR value as 1 so that I can enable or start the timer. Okay. Only after that the count value here will increase. As you can see, the value has incremented and that value is loaded into register R1. Since the timer continuously increments, its count acts as the source for our pseudo-random dice value. We then perform a logical shift right or LSR to select a different set of timer bits before masking the result to obtain values between 0 and 7. Here I'm comparing R1 with 6. If R1 is actually less than 6, we jump to valid. Okay. If that is not the case, then we are performing subtraction. And this subtraction will generate value 0 or 1. Because the possible value of R1 here could be 6 or 7. So when you subtract with 6, answer will be 0 or 1. Any value less than that will be transferred to valid. So here, since we have jumped to valid, we know that the value obtained is somewhere between 0 to 5. We are adding it with 1 because dice values range between 1 to 6, not 0 to 5. So then we load the address associated with the symbol, and then store the value 3 of that. We do this to clear the output register. Let's see even that. Our final output will be shown here. This will clear the output, and now we are loading the address associated with the symbol into register R0. We are storing the value that we obtained through the calculation into that location. You can see that the first dice output is 1, and then we branch to delay. Now the delay here is FFFF. We are performing subtraction here. So FFFF subtracted by 1 to generate FFFE, and then this loop continues until this value actually reaches 0. Once all that is done, we branch back to the address stored in link register, which will be this location. Okay, as you can see here, this address is stored in the link register because of branch with link. With branch and exchange, we will come back to this particular point. So I'll run this code continuously, otherwise we'll have to click multiple times for this particular delay to reduce. Okay, and because I'm doing that, let me just stop it here. It will jump back here, okay, which will branch back to roll. Over here, it will take the new count value, perform all the calculation, and store the final valid dice value into the output that is over here. Now let's see the values changing. You will see all values getting displayed here in random order. Let's continue running. As you can see here, 3 bits here represent all possible values of the dice, that is from 1 to 6. You can see the actual number in the last digit here, or the actual binary values through this bits shown here. That's all about this code.